nerves down the spine. How many people know that they have gotten chills before, or they consistently get chills? Okay, a lot of you guys, yeah, most people. These can happen to something like listening to music, or reading a poem, anything. I would invite you guys to come back down if you'd like. There are a few seats scattered around. Okay. So what are chills? How do chills happen? Well, chills are physiologically defined by an increase in heart rate, an increase in respiration, skin conductance, then sweaty palms, and a decrease in peripheral body temperature. Increased activity happens in the brain in certain areas when a chill happens. I will just list these. They're ventral striatum, dorsal midbrain, right thalamus, middle anterior cingulate, the right orbital frontal cortex, insula, supplementary motor area, cerebellum. And then activity is decreased in the hippocampus, the amygdala, and the prefrontal cortex. In particular, there are two areas that respond to chills, which are the caudate nucleus and the nucleus accumbens. This is the caudate nucleus. So imagine I sliced my brain this way, so you're looking down from the top. So this is the caudate nucleus, and this second part there is the nucleus accumbens. The interesting part is not in the brain regions activated by the moment-by-moment passing of a chill, but by the moment, the interesting part is not in the brain regions activated, but in the moment-by-moment passing of a chill. So for every chill, there is an anticipation phase and a resolution phase. And you can see this in the brain as well. This is supported by brain evidence. Now the anticipation phase, what happens is in the caudate nucleus, again, which is this, there's a rise in dopamine when you're starting to maybe heart rate is increasing, skin conductance is increasing, just slowly. And then when you actually feel a chill, where you feel the goosebumps or feel a shiver, it's reached a peak, and the nucleus accumbens shoots out dopamine. I guess you could say shoots out dopamine. There's a lot of release of dopamine in the nucleus accumbens. So what's interesting about this is that the caudate nucleus has been known in other studies to be involved in expectation, among other things. And the nucleus accumbens is widely known as a pleasure center of the brain. So this makes sense, expectation, and then a chill is just this pleasure that you feel when you get that chill. So that correlates in the brain. While dopamine was the target in a lot of these studies, or one study at least, opioids could also be what is released. There's a drug called naloxone, and that's an opioid antagonist, which has been found to block musical chills from happening, which suggests that the peak of musical chills could be related to opioid and other neurotransmitter release in the nucleus accumbens instead of dopamine. Endogenous opioid release. So endogenous means the opioids that are made within your brain. That's particularly involved in relieving pain, which is why we prescribe opiates. We give them to people in pain. Endorphins are like opiates, and heroin and morphine are example of exogenous opiates. Opioids cause both excitability of brain cells and also inhibition of GABA, which is a neurotransmitter that normally inhibits dopamine release in the nucleus accumbens. So that means when you inhibit GABA, you're inhibiting the inhibition, so dopamine is greater in the nucleus accumbens. A little more about dopamine. You might have heard of this as the pleasure molecule. The dopamine's released. Most neurons release glutamate. In fact, 95% of neurons release glutamate, which is another type of neurotransmitter. Less than 5% are the other types of neurotransmitters released by these cells. So dopamine is within the less than 5%, and it has a huge effect when it's released. It's not really known how this gives us the sensation of pleasure. What is pleasure is a very difficult topic to address. I did a study on chills, just a behavioral study, and I had participants come in and listen to excerpts of classical music, and then what they did was they reported when they had a chill, when they felt a chill, and then marked down the emotions that they felt at that point of a chill. I found a couple things out, that non-musicians felt significantly less chills than musicians. So musicians felt significantly more chills than non-musicians. And this was regardless of familiarity, which is pretty incredible. Like, people weren't familiar with each of the pieces. It's possibly due to the fact that musicians are more familiar with Western music, and therefore the structures and patterns and chord patterns. Because chills are due to anticipation and resolution, they may be able to anticipate a certain chord or climax better than non-musicians who don't have as much familiarity with that portion. I used something called the Geneva Emotional Music Scale, and this is a scale that's been used a little bit in the research world to represent what musical emotions are. These include, instead of the regular everyday emotions such as happy, sad, anger, fear, the GEMS scale uses tension, power, joy, wonder, transcendence, peacefulness, a couple more that I can't think of. So that's the scale I used. I have one more piece before intermission. I've gotten chills to it a couple times, because sometimes the association of nostalgia does that for me. In particular, my lolo, my grandpa in the Philippines, really enjoyed it when I played this piece. It's called Bayan Ko, meaning my country, and the country it refers to as the Philippines. This is a Filipino folk song that I want to share, in particular because of my cause for this recital. Again, for those of you who missed the beginning, I'm giving this in benefit of the Divine Mercy Foundation, an organization in the Philippines that provides for the medical needs of impoverished people. Thank you for everyone who sent in donations so far. We've raised a lot, and I think that the people there, as well as myself, will be I am, and they will be very, very grateful. So with that, I'd like to invite Sarah up. There will be